Hey everyone, Mr. Boykin here, Lesson 6, Unit 10, last lesson of the year. Here we go. So we're going to take a look at systems of linear equations, which means we're going to have be making two equations for a line and then solving for the x and y. So we got word problems here, and we got cashew nuts cost $22 per kilogram. We basically got this little cashew nut. Ain't that beautiful? And what do I know about it? It is $22 per 1 kilogram. So for 1 kilogram, costs you $22. And then we got Brazil nuts. Not sure what a Brazil nut looks like, but good enough. And that's going to be $16 per 1 kilogram. And we're basically going to be taking a little bit of each, putting it in a bag. We're going to have this mixed bag. So I've got this mixed bag over here of cashews and Brazil nuts. And basically it says that this will weigh 50 kilograms and it will sell for $18 for every kilogram that I want to buy. Now, the last sentence right here is, usually what is going to tell you how to make your x and y. So how many kilograms of each type will be in this final mixture? So we're just going to say let x be the number of kilograms of cashews, and let y be the number of kilograms of Brazil nuts. So I now need to make two equations. So I know I've got 50 kilograms in total. So the first equation is quite easy. It's like x, the number of kilograms of cashews, plus the number of kilograms of Brazil nuts, y, is going to equal the total amount, which is 50. Okay, now Brazil nuts are cashews are $22 per kilogram, and x refers to the number of kilograms. So if I multiply x times 22 and I multiply y by 16, that's going to be 22 times the weight, 16 times the weight, and over here it'll be 18 times the weight, but in this case we know the final weight is going to be 50. So there's my two equations right there. Now what I'm going to do is just move this one down, and I'll rework the first one. So this will become y equals y equals 50 minus x. So I'm just reworking this one so that I can use the y to substitute. Now I'm going to go down to this bottom one, 22 times x plus 16 times y. Well, what is y? Y is 50 minus x, and that equals 18 times 50, and 18 times 50 is 900. Just going to have to make this a little bit smaller here. Running out of room. Okay, and we will now sort of expand everything, gather some like terms, then just solve. So what do we have here? I've got 22 times x, and then I have 16 times 50. So 16 times 50 is going to be 800, so plus 800 minus the 16x equals the 900. So let's get all the numbers on the right hand side. So I'm going to subtract 800 from both sides. I'll end up with 100 over here, and I can gather the like terms. So I've got 22x and negative 16x, giving us a total of 6x's. And if I divide both sides by 6, I'm going to end up with 16.66666. So I get x equals 16.666, and that's sort of repeating. Now, you should recognize that 0.66666 is going to be the same as 16 and 2/3. And you can also do that conversion on your calculator, again, by going to the math button and choosing to convert that to a fraction. Okay, now it looks like here on the fraction, it's giving me an answer, when I'm looking at my calculator, of 50/3. Okay, but that can be easily converted back to here by hand or using the calculator. Okay, so now that I know that x is 16 and 2/3, I can just go back to my original equation, which is y equals 50 minus 16 and 2/3, and 50 minus 16 and 2/3 is going to be 33 and 1/3. So the final answer that we should have is the mixture will have now y, this one is y right here, so x is down below, so x was the cashews, so it's going to have 16 and 2/3 kilograms of cashews and 33 and 1/3 kilograms of Brazil nuts, and that is the final answer. Okay, we have another mixture question here. So Earl, the chemist, has made 180 milliliters of a hydrochloric acid mixture solution there. So we basically have this solution, and inside here there is 180 milliliters, and it has a 60% sort of dilution right there. And how did this Earl guy make this? Well, he had two bottles. So he had one bottle right here and another bottle right here. This one was, the first one was made up of a 45% solution, and the other one was a 70% solution, and mixed them together to get a 60% solution. So we look here, the last question again should allow us to set up our let statements. So how many milliliters of each? Okay, so how many milliliters of each? So let x be the number of milliliters of 45% HCl. Okay, so this is going to be my x right here, and this one will be my y. Okay, and the other one will be let y be the number of milliliters of 70% HCl. Okay, so from here, now that I understand the question, I need to formulate two equations. So I know I've got a total of 180 milliliters, and x is the number of milliliters. Y is the number of milliliters. So literally, it's going to be x plus y is going to be 180. So now, almost exactly like the last equation, I'm now going to use this 45%, 70%. So remember that 45%, we got to convert that to a decimal number, or that we can use with our math equations. So that's going to be 0.45. So 0.45 times that x plus the 0.7 times the y is going to equal the 180, okay, which is the total, but I'm going to need to multiply that by the 0.6 that is in the final solution. So there is our two equations, and again, I'm just going to move this one down, rework this one equation, so I get y equals 180 minus x, and then I just substitute. So 0.45x plus 0.7 times y. What is y? 180 minus x. And that's going to equal 0.6 times 180 is 108. Okay, now we're just going to sort of expand and gather like terms again. So 0.45x plus 0.7 times 180 is 126 minus the 0.7x equals 108. I'm going to move the 108 to the other side, or sorry, the 126 to the other side by subtracting both sides by 126. And we should get a negative 18 over here. So that sort of kills that. And now I'm going to combine the 0.5 and the negative 0.7, and I get negative 0.25x. And when I divide both sides by negative 0.25x, I'm going to get x equals a positive 72. And if I look at x, it's talking about the number of milliliters. I put an ml right there. Going back to my original equation, y is going to equal 180 minus the 72. So y is going to equal 108. And again, that's going to be milliliters. Okay, and now the final answer will be the solution has 72 milliliters of 45% HCl and 108 milliliters of 70% HCl. Done. Okay, that's number 2, solution. All right, and moving on to class example number 3, we're looking at some distance, speed, and time problems, and I'm sure you've also tackled similar type equations in your science class. You can see up top we've got this distance, speed, time triangle right here, and this is basically telling me that distance equals speed times time, and time equals distance divided by speed, and speed equals distance divided by time. So from that triangle, I can derive those 3 formulas right there. So let's take a look at what we have in our problem. So a student drove 1,245 kilometers. So what is that? That is a distance. Okay. And it took 16 and a half hours right here. So that's going to be a time. However, it did say here this included a 1-hour stop in Golden and a 30-minute stop in Kamloops. So currently I can see the distance that this person has traveled is 1,245 kilometers. The time it took to go that distance is going to be 16.5 minus the 1.5 where they stopped. So the total is going to be 15, and those are going to be hours. Now we've got this other one right here, which is going to be she averaged 100 kilometers per hour. And you can see right here, that is going to be a speed because there's distance, 100 kilometers divided by time, hour. So on the highway they went 100 kilometers per hour, and on the mountainous roads they went 75 kilometers per hour, a little bit slower. And again, from the last equation we should be able to sort of derive our let statements. So we're talking about how much time was on the 2 different types of roads. So let x be the time on highway, and let y be the time on mountain roads. Okay, and we need to now derive our formulas. So If X and Y are the time on the road and the total time driving was 15 hours, it makes sense that X plus Y, which are just time, is going to equal 15 hours, which is just the time. Now, the other number we have to work with is a distance, which is right here, 1,245. Now, if we notice the X is going to be time, now if we're going to be dealing with distance on the right, we need sort of distance on the left so that we have equal things that we're comparing. And if we look at this equation up here, how do we get distance? Distance is speed times time. So the X is time, and the speed on the highway was 100 kilometers per hour. So this is going to be a 100X plus 75Y. So it's going to, and remember, this right here is speed times time. So that is a distance plus a distance equals a distance. So distance on the highway plus the distance on the mountain is going to equal the total distance right there. So there's our two formulas, and once you have those, then it's just very simple. Right back to exactly what we did in the last two equations. Y equals 15 minus X. Substitute 100X plus 75 times 15 minus X equals 1245. Expand and solve. Expand, gather like terms and solve. So we end up with 100X plus 1125 minus 75X equals 1245. Subtract both sides by 1125, and I get 120 over on the right. Gather the like terms. 100 and negative 75 is going to be a 25X. Divide by 25, and we get that X is equal to 4.8. And because X is time, and in this case the units would be hours, go back to our simplified equation. Y equals 15 minus the X, which is 4.8. So Y equals 11.2. And again, those are going to be hours. And to put this in a word answer, which is usually required, the student drove 4.8 hours on the, and X is the highway, and 11.2 hours on the mountain road. Final answer. Lock me in. There we go. Okay, last one. We're still dealing with some distance, speed, and time, and it says we got a small little cruise boat. It traveled 36 kilometers for 3 hours down a river. So essentially there was this river and it went down, which happened to be 36 kilometers long, and it was going down. It took 3 hours to make that trip. Then it went up the river, so it would only make sense that it's going to take a little bit longer because you're going against the current. So the current is fighting you. So you're sort of going to have this, on the way down, what you're going to have is the speed of the boat plus the speed of the current. It's going to help you. So it's going to push you along a little bit. And down below, you're going to have the speed of the boat minus the speed of the current. So with the same power applied to the boat going down, you're going to be going faster because the current is going to help bring you increase that speed. And going up, the speed of the current is going to slow the boat down. Okay, and the last sentence again should help us create the let statements. So what is the speed of the current and the speed of the water? So let x be speed of boat, and let y be speed of current. Ugh. Okay, so we've got the speed of the current and the speed of the boat set up as x, y, let statements. Let's make this a little bit smaller, move it off to the side. Okay, now this one's a little bit trickier, but remember, we got that same thing. What is the 36? It's a distance. So if I've got a distance over here, I now need to have a distance on this side. So how do we create distance? It's speed times time. Now just up here, I showed you that when we're going down the river, the speed is actually a combination of the boat speed and the current speed, and those happen to be x and y. So that makes sense here. This would be an x minus y. And remember, the distance is going to be speed times the time. So on the first one up here, it's going to be 3. So 3 times the x plus y is going to equal 36. And that's when it's going down the river. And when it's coming back up, it's going to be 4 times the x minus y. And they still went 36 kilometers. Okay, so in this case, we want to expand both these out, so I end up with 3x plus 3y equals 36 on the top equation, and a 4x minus 4y equals 36 on the bottom equation. Now, I've got to figure out whether I want to use substitution or elimination, and the problem with using substitution is I'm going to end up with some fractions, so probably easier to use elimination in this case. So I need to multiply the bottom by 3 and the top by 4. So that is going to get me new equations that are going to be 12x plus 12y equals 36 times 4, 144, and 12x minus 12y equals 108. Now, what am I going to do? I can eliminate the y, and they're opposite signs already, so I am going to add these two together. So when we got 144 and 108, that's going to be 252. The y's will add together and be eliminated, and 12 and 12 is going to be 24 x's. And when I divide both sides by 24, I get x equals 10.5. Okay, so that part being done, we solve for our x. What is x? X is the speed of the boat. The speed is in kilometers per hour, so this is going to be kilometers per hour. And now I just need to solve for y. So essentially, I just need to grab one of these equations. So I'll grab this equation right here, and I'll just substitute that x with the 10.5. So let's do that. We're sort of running out of room. Let me just minimize a few things here really quickly. Make this a bit smaller. There you go. Okay, so we're going to take the 3 times the x, which is 10.5, plus the y, and we're going to say that equals 36. 10 times 3.15 is 31.5. 3 times y is plus 3y equals 36. Subtract 31.5 from both sides, and we have 3y equals 4.5. Divide both sides by 3, and we get y equals 1.5. And again, that's going to be kilometers per hour. And now I just need to write my final answer. So what is it? The speed of the boat. The speed of the boat is x. So the speed of the boat is 10.5 kilometers per hour, and the speed of the current is 1.5 kilometers per hour. We be done. That's it. The course is finished. See you in class.